Unit 2 Process Management. These are the 2-mark questions for Unit 2. Starting with the first question, what is a process? A process is an instance of a program in execution. It includes the program code, data, and system resources. The operating system manages processes through scheduling and synchronization. List the state of a process, which is the second question. The states of a process are new, ready, running, waiting, and terminated. New is the process is being created and awaits initialization, and then ready is the process loaded into memory and is waiting for the CPU execution. Running is the process is currently being executed, and then waiting is the process is paused while waiting for input output operation, and then terminated is the process has been completed execution or was forcefully stopped. Coming to the third question, what is process scheduling? Process scheduling is the operating system mechanism that selects which process will execute next. It ensures efficient CPU utilization by implementing short-term, medium-term, and long-term scheduling. The OS uses different scheduling algorithms like FCFS, SJF, and round robin, and also priority scheduling. Next, the fourth question, compare process and program. A program is a passive entity stored in memory, whereas a process is an active program in execution. And then moving to the fifth question, what are the main operations on a process? So the main operations on a process are process creation, process execution, process termination, process suspension, and process resumption, which have been explained briefly here. And what is inter-process communication? So IPC, which is the inter-process communication, allows processes to communicate and share data with each other while ensuring synchronization. It is crucial in parallel processing and distributed computing. It helps mechanisms like coordinate processes, prevent race conditions, and manage shared resources. The seventh question, name two IPC mechanisms. Shared memory. Shared memory processes share a common memory segment to exchange data efficiently. Message passing is processes send and receive messages through message queues, sockets, or pipes. And then moving to the eighth question, define thread. Thread is the smallest unit of execution within a process. Threads share resources of the same process. These are widely used in multi-threading models for parallelism and improved application interface. And then coming to the ninth question, what are the benefits of using threads? The benefits includes faster execution, efficient resource sharing, improved responsiveness, and parallel execution. Faster execution is they reduce context switching overhead compared to separate processes, and then efficient resource sharing is they share memory, file descriptors, and data within a process. And improved responsiveness is they allow an application to remain responsive while executing background tasks. And then parallel execution is they enable concurrent execution, improving CPU utilization. Moving on to the 10th question, name two multi-threading models. The first one is many-to-one model, and then the second one is one-to-one model, and third one is many-to-many model. Moving to the 11th question, what is the main drawback of first come first serve scheduling, FCFS? First come first serve executes processes in arrival order, which may cause longer waiting times. It suffers from convoy effect. So convoy effect is where short processes wait behind long ones, reducing system efficiency. FCFS is non-preemptive. And then coming to the 12th question, differentiate preemptive and non-preemptive scheduling. Preemptive scheduling, the OS can interrupt a running process and assign CPU time to another higher priority process. Non-preemptive scheduling is once a process has been started, it cannot be interrupted until it finishes. And then coming to the 13th question, what is starvation in priority scheduling? Starvation occurs when lower priority processes wait indefinitely due to higher priority tasks continuously being scheduled first. Aging is a solution to starvation, where the priority of a waiting process gradually increases over time. Coming to the 14th question, how does round robin scheduling work? Round robin scheduling assigns a fixed time slice quantum to each process in the ready queue. Then, when a process time quantum expires, CPU switches to next process in the queue. If a process is not completed within its time slice, it moves to the end of the queue for another turn. And then finally, the 15th question, how is fairness achieved in round robin scheduling? Fairness is achieved by giving equal time slices to all processes in cyclic order. Each process gets an equal time slice of CPU execution, preventing monopolization. The scheduler rotates through the queue in a cyclic manner, ensuring no process is indefinitely delayed. Shorter time quanta improves responsiveness, while longer quanta reduces context switching overhead. And that's it with the Unit 2 2-mark questions.